This is integration. Firstly, just a small reason as to why we study integration. We have done differentiation in the previous topic, which was the first part of calculus. The second part of calculus is integration, and it is the opposite of differentiation. For real-life application, it is used in planning spacecraft flight paths, modeling real-world behavior for computer games. But what we will focus on for the part in Pure 1, or math in general, is to find the area or volume of functions. Now we are going to look at that a bit later on, but for now we have to get the basics right. So as I just said, integration is the reverse of differentiation. So we already know that if y equals to x power n, then dy over dx, which is a differentiation, is nx power n minus 1. You take the power down, multiply it with the entire term, then subtract the power by 1. But we also know that if you have a constant, then that constant goes away because it's x power 0, and if you take down the power, you're multiplying the whole thing by 0. And so that constant just disappears when you find the differentiation. As you can see here, all these are all x cubes with a certain constant, all different, and they all give you a differentiation of 3x squared because only the first term is getting differentiated, since the second one is a constant and will just go away. Therefore, there are an infinite number of functions that, when differentiated, give you 3x squared with all the different type of constants you can have. Let us try finding the derivative for all of these. Then we'll analyze all of them and see if we can come up with a formula for the integration. So this one right here, the power you multiply to the initial, so 3 times 1 over 3x, and then power minus 1, so power 2. The constant just goes away, this just gives us x squared. This one right here, you multiply 15 times 1 over 15 x power, 15 minus 1, which is 14, the constant just goes away, you end up getting x power 14. This next one, you take negative 7, you multiply by negative 1 over 7 x power, negative 7 minus 1, which is negative 8, constant goes away, we end up getting x power negative 8. 1 over 6 x power 6, you multiply the 6, which comes 6 times 1 over 6, x power 6 minus 1, which is 5, then the constant goes away, this just gives us x power 5. Then here, negative 2 times negative 1 over 2 x power negative 2 minus 1, which is negative 3. Constant goes away, we end up with x power negative 3. Then the final one, 3 over 2 multiplied by 2 over 3, x power 3 over 2 minus 1, which is just 1 over 2, which is equal to x power a half. Constant obviously goes away for each. Now, try finding a rule to get back y if you have your dy dx. So how do you go back to this right here? How do you go back to this, for all of them? How do you get from the answer you just got, the derivative, and go to the original equation? So if you see, all the derivatives are just in the form x power n, 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 and x power n. So how do you go back to the original? If you notice what they've done, for all of them, we have taken the power, we have added 1 to it, yes, to get x power 3. Then we have divided by that same number that we got after we added, so 3. X power 3 over 3. Here, x power 15 over 15. You add 1, then divide by that number. Here, add 1, you get x power negative 7, divide by negative 7. So you get negative x power negative 7 over 7. Here again, same thing, you add 1, becomes x power 6, divide by that same, added by 1, so 6. Then here, same thing, x power, you add 1, you get negative 2 over negative 2. Here, same thing, x power 1 over 2 plus 1, which is 3 over 2, over 3 over 2, which is just 2 over 3 x power 3 over 2. So all of them, what you have done is, if you had an x power n, what happened is you took your x power n, added 1 to it, so x power n plus 1, and then you divided it by that same n plus 1. And that is how we will integrate anything of this form, x power n. Because remember, integration is reverse differentiation. So we differentiated the first time, then we went back to the original. However, I want you to notice something. We didn't account for these numbers right here because we do not know what they're going to be. Because when you differentiate, that number practically goes away. And so to get back your integration, you will not know your number unless you have been given more information. So for now, whenever you integrate, your constant, you're not going to write it as a number because you don't know what it is. So since it does exist, but you don't know what it is, we can give it a variable. We call that usually c. So we have your integral, the one you find after you integrate, which is x power n plus 1 over n plus 1 for questions of this form, the x power n form. Then we will add c to it, plus c, because it can be any constant there. Now, does this work when we try to integrate this thing right here? So suppose we got our dy over dx to be 1 over x. How do we go back to our original equation? So how do we integrate it, reverse differentiate, and we do that? So let's try this formula that we got. Remember, 1 over x is just x power negative 1. And the way we did it was we added 1 to the power, so x power negative 1 plus 1 over negative 1 plus 1. This gives us x power 0, which is valid, which is just 1, but we divided by 0. And we know that anything that is divided by 0 is undefined. So this rule that we just found, the x power n plus 1 over n plus 1 plus c, only works for all n's if they are not equal to negative 1. The moment n is equal to negative 1, we have to use another way. The symbol for integration, this thing right here, which looks like a longer s, is used to identify when we want to integrate. So, for example, if we want to integrate x squared, we will write that s sign, then x squared dx. This means integrate x squared with respect to x, meaning using x as your variable. And that obviously will be, you add 1 to the power, x power 3, then you divide by that number. So n plus 1, which is 2 plus 1, which is 3. So x power 3 over 3, then we have our plus c because it could have been any constant there. That is known as an indefinite integral because we don't exactly know the value of it because we don't know the value of c. So it can be anything. It could have been 1 over 3 x cubed plus 500,000. It could have been 1 over 3 x cubed plus 0. And it could have been anything in between. Therefore, we don't know what exactly it was, and that's why we call it the indefinite integral. Now, here are a few rules of integration. When you are integrating powers, which we just did, x power n with respect to x, we will take the x power n plus 1 over n plus 1. Then we will add our c, where c can be any constant and n cannot be equal to negative 1 because we get the form of over 0, right, which is not possible. When we are integrating constant multiples of a function, meaning a function that is multiplied by a certain value, for example, if we have x squared can be the function, and we have multiplied 2 outside, so 2x squared. The way we would do this is just take 2 out of the integral. So 2 integral of x squared. So you just integrate x squared with respect to x, obviously. Then you will multiply by 2 at the end. And this works where k is any constant. Finally, if you are integrating sums and differences, just like differentiation, so if we have x squared plus 2x, where this is a function on its own and this is a function on its own, then to integrate both of them, like within a function, we can even separate it. So we can write it as integral of x squared plus integral of 2x. And we integrate both individually. Obviously, both being with respect to x. So here dx, dx, and dx. Let's do a few examples of these. So find y in terms of x for each of the following. So we have been given that differential. We have to integrate it to find our original equation. So if you integrate the left side, the integration of dy over dx is just going to be y because it's the opposite of differentiation. Remember, we differentiated this to get our dy over dx. So to integrate this, we will get back our y. Then integrating the right side, what we will do is x power 3 plus 1, n plus 1 over n plus 1. So 3 plus 1 here, which will give us x power 4 over 4. But we don't have to forget the plus c, because it could be anything as the constant. Then for b, same thing again, integrate the left side, we get y. That is equal to, remember this is just x power negative 2. So we'll use the same rule that we have because n is not equal to negative 1. And so x power negative 2 plus 1 over negative 2 plus 1, which is equal to x power negative 1 over negative 1, which gives us negative 1 over x. Then obviously you don't forget the plus c. Next, we're doing the same thing. We have the differential of the function f prime of x, and you want to find f of x from that. So we are reversing that, therefore we have to integrate this entire thing. So 4x cubed will just become, remember, you just take the 4 multiplied by whatever you are integrating here, so x power 3, which is just going to be x power 4 over 4. Then this is just negative 2 x power negative 2, which again, you write it as your negative 2 as it is, then multiply by negative 2 plus 1, so x power negative 1 over negative 1. Then the 4, remember 4 is just 4x power 0. So we will write our 4x power 1 over 1, because 0 plus 1 is 1. Then obviously we have our plus c, which we have whenever we integrate anything indefinitely. So this will just become x power 4 plus 1 over x plus 4x plus c. And that is going to be our function f of x. For the next one, we can start off by writing it in a good form. So 8x squared minus 1 over 2x power negative 4 plus 2x. Remember, the power is only on x. Therefore, if you want to switch x upwards, we will only apply the negative 4 to x, not to 2. 2 is already down, and it will remain in the denominator. So that right there, we can now start integrating it. And for the starters, we'll have f of x is equal to 8 times x power 3 over 3, because n plus 1. Then minus a half times x power negative 3 over negative 3, negative 4 plus 1. And then plus 2 times x power 2 over 2. Then obviously we'll have our plus c at the end because everything has a plus c. This will give us 8 over 3x cubed plus 1 over 6x cubed plus x squared plus c. And that is going to be our function f of x for this f prime from b. So for c, what we will do first is expand the numerator. We will get x squared plus 2x minus 3 all over root x. Then what we can do is differentiate all the terms and make them individual. So x squared over root x plus 2x over root x minus 3 over root x. And that is equal to x power 3 over 2 plus 2x power a half minus 3x power negative a half. Now we have to integrate this right here to get our original function f of x. And we will get that f of x is equal to x power 3 over 2 plus 1 over 3 over 2 plus 1 plus 2 times x power a half plus 1 over a half plus 1, then minus 3 times x power negative half plus 1 over negative half plus 1. This will give us x power 5 over 2 over 5 over 2 plus 2x power 3 over 2 over 3 over 2 minus 3x power a half over a half. Then again, rewriting this, we will get 2 over 5 x power 5 over 2 plus 4 over 3 x power 3 over 2 minus 6x power half. Then we obviously have our plus c at the end. And that will be the function from this derivative right here. Next, we have to find the integral of this thing right here with respect to x. So firstly, we can just expand it and we will get 2x squared minus x multiplied by 2x plus 3. And that will equal to 4x cubed plus 6x squared minus 2x squared minus 3x. And rewriting this 6x squared minus 2x squared, we just get 4x squared. Then what we can do is we can integrate this entire thing right here. And remember, the integral of this entire thing will just be the integral of these individuals. So we can write this like this with respect to x, obviously. So the integral of 4x cubed is going to be 4 times x power 4 over 4 plus 4x squared is going to be 4 times x power 3 over 3. And then the integral of this is going to be minus 3 times x power 2 over 2. Then we have our plus c at the end, which is our constant. This will give us x power 4 plus 4 over 3 x power 3 minus 3 over 2 x power 2 plus c. That is the answer for A. For B, what we will do here is split the numerator. We will end up getting 4x squared over x minus 3 root x over x. This will give us 4x minus 3x power negative a half. And we have to find the integral of this with respect to x. This just means we find the integral of each of these. The integral of 4x is going to be 4 times x power 2 over 2. The integral of this is going to be negative 3 times x power negative half plus 1, which is half over half. Negative half plus 1 again. Then obviously we have our plus c. This will give us 2x squared minus 6x power a half plus c. And that right there is going to be our integral for B. Next up, we're going to see an example where you're actually finding that plus c. So a curve is such that the derivative of that curve is 6x power 5 minus 18 over x power 3. And we can write that as 6x power 5 over x power 3 minus 18 over x power 3, which is just going to be 6x power 2 minus 18 x power negative 3. Then we also have that this right here is a point on the curve. Then we're told to find the equation of the curve. So we want to find our equation y. So y equals to something. From this right here, we will have to integrate this in order to get our y. Right? So we integrate this right here, which will give us 6 times x power 3 over 3 minus 18 times x power negative 2 over negative 2. And then obviously we have our plus c. This simplified will be 2x cubed plus 9 over x squared. Then we have plus c. This right here is the equation of the curve. But we know that this is a point on the curve. So when x is 1, y is always equal to 6. So we can try to do that. Y equals to 2x cubed plus 9 over x squared plus c. And when x is 1, y is 6. So 6 equal to 2, 1 cubed plus 9 over 1 squared plus c. And from this we get 6 minus 2, subtracting 2 on both sides, and minus 9 also, subtracting 9 on both sides. We will get our c equals negative 5. Therefore, our equation is going to be y equals to 2x cubed plus 9 over x squared minus 5. So all we needed was the derivative and 1 point on the curve. And from that, we found the entire equation of the curve, including that c value that is always disturbing. Next example, the function f is such that f prime of x, which is the derivative, is 15x power 4 minus 6x. And in the function, if you put in the input of negative 1, you will get the output of 1. Now we have to find f of x. So for that, firstly, we'll need to integrate this. So we integrate 15x power 4 minus 6x. That is going to be 15 times x power 4 plus 1, which is 5, over 5, minus 6 times x power 1 plus 1, which is 2, over 2, and we obviously have plus c, and that is going to equal to f of x. Then we will have 3x power 5 minus 3x power 2 plus c is equal to f of x. Remember, if you put in -1 as your input, so in place of x, we will get 1 as our answer. So f of -1 is equal to 3 -1 power 5 minus 3 -1 squared plus c, and that is going to equal to +1. This will give us -3 minus 3 plus c is equal to 1. Therefore, c will equal to 7. Therefore, what this gives us, our f of x is equal to 3x power 5 minus 3x squared plus 7, which is our c. Final example, a curve is such that the derivative is 6x plus k, where k is a constant. The gradient of the normal to that curve at this point right here, when x is equal to 1, is a half. Find the equation of the curve. So there's a few things going on here. Firstly, the gradient of the normal is 1 over 2. We have been given the dy over dx, which is the gradient of the curve at a specific point. And the gradient of the curve is just the gradient of the tangent. Yes, gradient of tangent. And that tangent is obviously perpendicular to the normal. Therefore, if the gradient of the normal when x is equal to 1 is a half, the gradient of the tangent when x is equal to 1 is going to be the reciprocal of a half times -1. So it's going to be -2. This is going to be the gradient of the tangent, and so the gradient of the curve when x is equal to 1. Therefore, 6x plus k, which is equal to dy over dx, which is the gradient of the curve. When x is 1, the gradient is -2. Therefore, 6 times 1 plus k is equal to -2. This will give us our k to be -8. Now we have that our dy over dx is equal to 6x minus 8. And we want to find the equation of the curve. Therefore, we want to find our equation of y. For that, we'll need to integrate our dy over dx. Integrating this will give us 6 times x power 2 over 2 minus 8 times x power 1 over 1 plus c. This will be 3x squared minus 8x plus c. Obviously, y is equal to that. But we don't have our value of c. But what we do know, from the information given, we know that this is a point on the curve. Therefore, when x is 1, y is equal to -3, and we're going to do that here. So -3 is equal to 3, 1 squared minus 8 times 1 plus c, which will be -3 is equal to 3 minus 8 plus c. So -3 equals to -5 plus c. Therefore, c is equal to 2. Then rewriting this as our equation, we will get y is equal to 3x squared minus 8x plus 2. That will be our equation of the curve.